Okay, guys, today we're going to talk about how to find vertical and horizontal asymptotes. In particular, this question right here, where it says, give the equations of the vertical and horizontal and or oblique asymptotes of each rational function. Again, in this case, we're going to focus on the vertical and horizontal. Later, we'll talk about how to find oblique. Remember, oblique is also called a slant asymptote. Okay, let's start with the vertical asymptotes. By definition, vertical asymptotes occur at the values of x that make the denominator equal to 0. So in this particular case, this rational function has already been factored. If it hadn't already been factored, that would be step one. We would want to go ahead and factor it, but that's already been done for us. So what I'm going to do is I'm going to take my two factors, in this case 5x minus 1 and x minus 5, and I want to set both of those equal to 0. If you think back to earlier in the year, we discussed how to find the domain of a rational function, and what we did is we set the denominator equal to 0. So it's a very, very similar process. So if I go ahead and work this out, the one on the left, I'm going to get x equals 1/5. So that's it for one of them. And the one on the right, I'm going to go ahead and add 5 to both sides, and I get x equals 5. So my two vertical asymptotes for this particular problem are going to be x equals 1/5 and x equals 5. That's it. We're done with the vertical asymptotes. So let's move on to the horizontal asymptotes. For horizontal asymptotes, what we want to do is we want to take a look at the degree of the polynomial on the top, and we want to look at the degree of the polynomial on the bottom, and we want to compare those degrees. The disadvantage of being in factored form here is it's not obvious to me what the degrees of the top and bottom are. So what I'm going to do first is I'm going to FOIL out these two factors. So I get x squared minus 2x minus 8. And on the bottom, I would get 5x squared. It's going to give me minus 26 plus 5. Okay, on the top, I'm now going to distribute that 3 that was out in front, so I end up with 3x squared minus 6x. Sorry about that. Let me erase that there. So again, 3x squared minus 6x, and then minus 24. On the bottom, nothing changed, so I'm just going to go ahead and clone what I had just done there. And I get this here. Okay, so that is the standard form of the original polynomial. Now, the reason why that helped me is now it's very obvious to me what the degrees are. Remember, the degree is the highest power of the polynomial in standard form. So if I were to look at the highest powers, I notice that they're both second degree polynomials. Therefore, that puts me in this scenario where if I have a rational function where the degrees are the same, I take the ratio of the leading coefficients. A is the leading coefficient on the top, B is the leading coefficient on the bottom. Therefore, in this particular problem, the horizontal asymptote would be y equals 3 over 5. And I'm done. Now, the other scenario is if I had a higher power on the bottom. Let's say hypothetically that instead of 5x squared, this was 5x to the third. So I have a bigger power on the bottom. What that would mean is that the horizontal asymptote would be y equals 0. So let's kind of recap there. If the degrees are the same on the top and bottom, we take the ratio of the leading coefficients. If the degree were bigger on the bottom, so if my degree down here was larger than the degree on the top, then my horizontal asymptote would be y equals 0. Now graphically, let's talk about what this means. So if we wanted to plot the vertical asymptotes and the horizontal asymptotes, what we would do is we would actually draw dotted lines at those particular places. So if I were to go back, remember we said that the vertical asymptotes were 1/5 and 5. So what I would do is I would go over to 5, and I would draw a dotted line at 5. So 1, 2, 3, 4, 5. Draw a dotted line down. I would also go to 1/5. We would have to eyeball it, be right about there. And then for the y-intercept, we said that, or sorry, for the horizontal asymptote, sorry, we said that it was y equals 3/5. So again, I would kind of have to eyeball it, but 3/5 would be right about there. And there are my asymptotes. So we're going to